Hi everyone, I'm excited to talk to you about PASHA, efficient hybrid optimization with progressive resource allocation. I have developed this method together with Lucas, Beisa, Cedric, and Giovanni during my internship at Amazon. The selection of hyperparameters and neural network architecture has large impact on the performance of the model, so selecting them randomly will not be enough for obtaining excellent performance. For example, in NASBench 201, various architectures lead to significantly different performances. In HPO and NAS, there are several challenges, especially if you work on a large scale with huge datasets. In fact, costs can make a large-scale HPO difficult and often unviable. For example, a simple approach which evaluates only 10 configurations for a larger better model will cost around $100,000. Another challenge is that multi-fidelity methods such as ASHA require specifying the maximum amount of resources. But how do we specify this number? In practice, we almost estimate its value to guarantee convergence, while excellent configurations could be found using far fewer resources. One key insight that could be useful to significantly reduce the amount of resources needed is that the ranking of configurations is relatively stable after the initial part of training. This means that the learning curve rarely crosses in later stages of training, of course excluding noise that is very common while training neural networks. Drawing upon this insight, we develop PASHA, which is a variation on ASHA. The key idea is to dynamically increase maximum resources depending on if ranking of configurations is stable. We start with a small initial amount of maximum resources and progressively increase them if the ranking of the configurations in the top two ranks, or rounds of promotion, has not stabilized. Of course, the progressive increases are only up to a certain limit, so we do not increase the resources infinitely. Due to stochasticity, some benevolence in rankings is needed, so we use soft ranking. The use case is that we identify the best configuration using PASHA, and then retrain on the whole dataset for full number of epochs. PASHA is particularly useful for massive datasets where the rankings are likely to stabilize early. We illustrate how PASHA stops early on a diagram. On the left side, the ranking of configurations is the same in the top two ranks, so we stop and return the best configuration. On the right side, the ranking has not stabilized, so we continue promoting the best configurations into further ranks, consuming more resources. Let's explain some of the ranking next, as it is the key part of how PASHA decides on resource increases. As part of soft ranking, each position is represented by a set of configurations that have performances within a given range, with the range defined by epsilon. I will go through the ranked list of configurations in the top rank and check if the current configuration at the given rank was in the list of configurations for that rank in the previous rank. Now is the time to look at the results. PASHA finds similarly well-performing configurations as ASHA, but at a small fraction of the time, for example 1/2 or 1/3 as we can see in the table on the slide. Using PASHA can save a lot of commercial resources without sacrificing the accuracy. PASHA is also compatible with search strategies based on Bayesian optimization. Using Bayesian optimization, we improve the accuracies compared to random search strategy, with PASHA still saving a large part of computational resources. We have further done experiments on large datasets that have millions of examples and tens of gigabytes of data. For example, code has about 25 million examples and 16 gigabytes. PASHA can measure performance of ASHA in most cases and consumes a small fraction of the time. For example, 1/5 of the time needed by ASHA, an already efficient method. So PASHA makes the largest difference on large datasets with millions of examples. To summarize, we have presented PASHA that dynamically selects the amount of maximum resources. It leads to significant speedup of HPO and NAS without sacrificing the performance, and is particularly useful for large datasets. It can also be combined with Bayesian optimization search strategies. PASHA is available within Fine-Tune HPO framework, so you can easily use it in practice. Thank you very much.